Thank you. Good morning. Well, I need to present this new, old idea, but a new concept in the model code. Conceptual design is something everyone knows that we have to use, but it is not so easy to explain and not too easy to give a procedure to do good conceptual design. So, what is conceptual design? Well, conceptual design is something you need to pass from a problem like this to a good solution. This is conceptual design. Seems too easy, but it is very difficult. When you have a problem, for example, this one, you need to understand well the conditions you have to solve, the problem you have to solve, and you start with a blank page like this one. And then you need to think, to have good solutions, to make a synthesis of many things, and then to propose a solution and to improve all the time. So you need to start understanding the problem, making sketches, not calculations. You need to know a lot of knowledge, but to use in producing a good solution, and you can make many different solutions, and at the end you need to select one between many, and to propose a solution. But this is a very difficult process, and it is more difficult to really give simple rules to how to proceed. So I would like to start with this example. It's a very old one, but for me it's the best example of good conceptual design. It was produced in the 2nd century after Christ, and he had some knowledge, not much as we have now, but he, Apollodoro de Damasco, was able to produce this incredible structure, plain concrete, the right shape in order to take advantage of the plain concrete. And you can compare these two structures. The distance in time is practically 1,300 years, and the diameter of this structure is a little bit bigger than that one. So he was very good. He took advantage of all the resources in order to make a good solution. And now we have a lot of models, we have computers, we have many things, and we, in many occasions, are not able to produce such good structures. So we need to study this example carefully in order to be able to get conclusions. So we have not that example. We have many examples in our engineering history. We know badly our history, and this is terrible. But at the same time, we have very good examples, and in order to to make an exercise and to try to find the conditions you need to make a good conceptual design. I found at least these four conditions. First, you need to have a deep knowledge. As you could see from the previous presentation, Model Co give you many good models, many good ideas, many good solutions to many problems. But then you need to summarize all that and to produce a good solution. You need to understand well all that, and you need to have a very wide vision in order to obtain good solutions, good structural solutions. So this is these are pictures taken from a book wrote by Eduardo Torroja, an eminent engineer, professor, and researcher from Spain. And you see how you deeply know many things to produce good solutions. And the second condition, according to my opinion, is to really work hard in order to find a solution. You need to have ideas, but to explore many ideas, to enjoy making many proposals and thinking and criticizing your proposals in order to obtain a nice structure like this one. It's made in steel, but it's a good one. And probably you need a lot of experience. You need to learn this process, and you can take advantage from previous experiences. And it is interesting also to be open-minded and to be able to work in different fields with different materials and along the life cycle, because you can learn a lot from the existing structures, and you can take advantage of this information for the new structures. It is easy to say all that, but then you need to really take advantage of all this information to produce good structures. And for me, it's very important, and I had the pleasure to share some sessions here in this Congress. And I think we need to not to forget that we are working for them, and we need to always have in mind that our main goal is to satisfy them, and this can motivate you to do a good work. So this was written by Eduardo Torroja. Probably not all of you know him. He was a very interesting engineer. You can read some of his books and papers, and he had clear that in order to make a good design, you needed to have a deep knowledge, but at the same time you had to have a part of art, common sense, attitude, pleasure in imagining harmonic layouts, where, and this is very important, calculations will add only the final touch with the splendor of its static resisting guarantee. So this is probably something you have to take into account. Now we are very used to make calculations, to make models. Reality is very complex. It is very difficult to represent reality. We have many tools, we have much more information than before, but at the same time we need to produce good design, and this is very important. let me give you some historical examples. This is a problem Torroja had when he started working as an engineer. He was at that time 26 years old, and his problem was to try to produce a new solution in this aqueduct without founding these two piers in the middle of the river. And his idea was, well, we can eliminate these two piers using these stays, and it was probably one of the first examples of stays solutions. So this is the idea. The idea was very good. And then he needed to develop many things in order to make possible that idea. And here you have some explanation. At that time, it's not like today. You call somebody to provide you the stays, and they are in charge of for the fabrication, and also they install the stays. But he needed to think how to produce the stresses of these ropes, and he had the idea to put jacks on the top of the pylon and to push up this part of this concrete saddle in order to put the forces in the stays. So you see how he had the idea, and also he could develop the way to make possible the idea. And here you have, there are many other things I could tell you about that, but I want to go a little bit further. Here you have another example. It's another aqueduct. It was designed a little bit later. But the main idea in this case was, well, we don't have pre-stressing. The pre-stressing at that time was not developed in like it is today. So his idea was, well, it's an aqueduct. I need to avoid the water to go out, so I need to have a good idea. It is not so easy to install cables with the right layout. He was able only to use straight cables, and in order to take advantage of that, he thought to have this solution is a simple span with two cantilevers. The cantilevers has the same length as half of the span, so you have only negative moments, and if you have negative moments, you have the tensile cord on the top of the cross section, and if you have that, you can use these straight cables, and this is conceptual design. You have the idea to solve a problem, an efficient idea. And in order to pre-stress the cables, he invented this system. Here you can see a jack in between these two steel elements, and with this jack he could pre-stress the cables. It's incredible. And also he took some measurements in order to pre-stress the transversal cross-section. So many ideas. But he was not the only one. We have many other examples. Maillard, for example, I like very much this project in which you can read the bending moments law in this proposal. It is very, very smart, but he was very good. We have many examples, also in other countries. Fressinet, Pierluigi Nervi, he to make this roof in Paris, he had the idea to use these triangular cross sections, but in order to take advantage of concrete, he used a slab which was moving up and down in order to have concrete in the places you need concrete. For negative moment, you need the concrete in the bottom part because you compress the bottom part of the cross section in the mid span where you have a positive moment. You need the slab in the top part. So he was moving up and down this slab in order to make a more efficient the use of concrete. So this is conceptual design too. I like very much George Schleich. He is a reference for me, and he has many good projects. You probably know many of them. But we are doing this type of structures at the moment, in many occasions, unfortunately. It is very difficult to read all the knowledge we have at the moment if you see this type of structures. We have now the Eurocode, the model code, I'm sorry. As Joost was explaining in detail, the model code have 4 different parts. And in the design chapter, at the beginning of the chapter, we have a clause here talking something about conceptual design. So I am very happy to say that for me it's the first time, or one of the first time, we have that clause in a chapter of design. I don't know if the content is completely, we need to develop that also. It is, as I said at the beginning, for me, I think it's very difficult to make a synthesis of that process. But we have now conceptual design here, trying to indicate that it's very important to have good ideas. And we have also in our structural concrete textbook a long chapter or paper about conceptual design. So we have some more indications to explain a difficult problem or a difficult process. So I don't know if this is the right definition, but I think conceptual design could be a definition. Conceptual design is an ability that is acquired through time. It requires a great effort. You have to work hard in understanding the requirements. This is very important. In many occasions, you see the young engineers trying to make calculations after understanding the problem, so they are losing a lot of time. So you need to know the requirements and the problem. It requires an ample engineering and human culture. We need to interact with the architects. We are criticizing all the time the architects. We need to interact with them. We need to teach them, and we need to learn from them both in order to be sensible to the many variables involved in the design. It requires a great ambition, which is a trademark of those who in any engineering activity look always for the best solutions. It requires experience. You learn with your own experience, which is a process of learning from successes and failures. It requires a hard work also and the ambition to try to do the best till the last moment. So let me give you an example, and let me go through the content of our conceptual design part in the model code. This is the result of the work we have done in my office for a competition. We lost the competition, and I would like to show this because it was a lost competition. But we made two proposals for the same problem, and here you have the chart you can find in the model code, trying to summarize what you have to do, but it's a very difficult problem to be explained only in a chart like this. Well, you need to really understand the problem, and this is very difficult. We don't need to spend a lot of time on that. We don't have we are not used to do that. We want really to find models and to make calculations, but we need to understand the problem. In many occasions, you can avoid problems and or minimize problems, and it is the best way to estimate or calculate problems. If you have a crack problem, and if you minimize the crack problem with a good conceptual design, you will not need to have a very accurate model to evaluate crack width. I don't want to say that crack width models are not useful, are not interesting. They are. But at the same time, we need to know the limitations of the models we have now, and we have to understand that if we need to avoid cracks, we need to use pre-stressing, for example. This is a concept. But for having a good solution to a problem, we need to really understand the problem. And in this competition, we needed to make a lot of previous work in order to see the history of the city. It was an urban bridge, and we needed to visit the place and to think how people was living in that place. So, and finally, you can define certain general conditions. You can update these conditions. You can have first one list, and then you need to be open in order to introduce more in the process of the design. And you have many tools, but I think you need to think, and you need to produce good sketches. I believe strongly in the tip of the pen. For that reason, I like to make drawings, because I think that when you make a drawing by yourself, you are connecting your neurons with the problem. So I really like to make sketches, and I think it's a very good first step. So you, for example, in this case, you have the river, you have the road, and the crossing was askew, and you have many different possibilities to design the position of the piers and the position of the abutment. And at the end, we were studying many, because you can make you can use this solution in which you have the piers and the abutment perpendicular to the layout of the road, or you can do that parallel to the river, but you have always another possibility, and in this case we adopted, and you will see why. We adopted this triangular shape for the abutment, in which you can take advantage of the direction of the river, and we finally decided to use only one pier in order to minimize the interaction. So if you think, you can produce ideas. And then you can check, you have to check many different possibilities, and here you have many or some of the possibilities we were checking. And at the end, you need to take a solution because you have a limited period of time for doing that. But you see here that the solutions, you can improve the solutions always, all the time. And these are the final solutions. These were the state in which we took the solution, the decision to develop more these two solutions. And probably you can't see the differences, but there are many differences between that moment and the final presented proposal. So, for example, with this suspension proposal, we had experiences very important because it is not so easy to enter in a subject without having experience, and you need not to lose any opportunity to do a good design, because when you have the possibility to solve a problem like this, you have the custom to follow this process. And this is a competition, this is a cable, a suspension bridge we designed, and I want to tell you that because of the importance of the experience. You have here, it was a competition we won in '91, more than almost 25 years ago. And the idea was not, it is clear that the suspension bridge is a good solution for very long span, but we wanted to try this possibility, this solution for shorter spans. And the idea was to minimize the cost of the main cable, and in order to minimize the cost of main cable, we used cables produced for cable stayed bridges. And if you do that, the main cable have to be formed for many stays. And if you do that, you need to refine a little bit the connection between the cables and the deck. And if you do that, you have the possibility to use the same way you install the cables to replace the cables. So if you think and you think and you think, you always have the possibility to improve your design. And why one pylon? Because this is the new part of the city, and here you don't see, but it was the old part of the city, and we didn't want to compete really with the new part of the city. And we had a pylon of 40 meters, and we leave an stair inside the pylon in order to allow the people to go up. So you always have possibilities to develop ideas. So yes, when you have experience, then you have more possibilities and so on. This is another project which is under construction at the moment, and it is in the south of Chile, and the main span is around 1,200 meters. And the two spans are completely different, and the conceptual design in this case was the differences of the two spans and the necessity to avoid horizontal forces for permanent loads, and you have to play with the height of these two pylons in order to have the equilibrium in the central pylon for the permanent loads. So the examples. And finally, here you have the solution, and I want to show you the drawings we presented at that time, and I want to concentrate myself in two things. This is the shape of the pylon. The shape was defined in order to interrupt the river, the water of the river underneath the deck, and to be able to receive the cables on the top of the pylon. And this evolution from the foundation to the top of the pylon, you can improve a lot if you work a lot. And this is the second aspect I wanted to tell you. This is, according to the proposal, this was a self-anchored suspension bridge. And you see here that the main cable can introduce the compression into the deck directly, and you need to equilibrate the vertical force of the main cable, and in order to counterweight this vertical force, we were thinking to use all the abutment. So the abutment is in fact the counterweight in order to equilibrate the vertical. So, and then you need to think about the construction process. In many occasions we are far from the construction, and it is very, very important to develop your ideas and to reach, to go to the final definition. And here you see an explanation. Our idea was to launch the deck, and then to install the main cable, and then to install the hangers. And for that, again, the previous experience is very important. You don't need to have this experience when you finish your degree. You need not to lose any opportunity along your life to try to enter in detail in every project, and to learn as much as possible in order to take advantage of that in the future. So here you have other experiences. I will not go into detail. And finally, I would like to say 2 or 3 words about the details. The details are very important, and you don't need to do special things. You need to treat concrete, our well-known concrete, in an accurate way. When I see Tadao Ando's structures and I see how nice they are, I ask myself why we are not able to ask the constructors to produce structures like this. Probably is because we are not thinking in all the details you need to develop in order to obtain a good construction. You need to define the formwork in a very detailed way in order to have the final result of the concrete as you really want. And finally, we need to go into all the details. This was the idea we had in order to convince the jury, and we didn't because we lost the competition. But this was the idea, which we wanted to paint our bridge, and we wanted to show the combination of the colors we were proposing for the bridge, and we used a picture of modern art in order to make the relationship between what we want to, how we want to combine the colors, and you have different proposals. And I wanted to, my final idea was this one, because it's an area in which there are many vineyards, and at the end of the summer, the color of the vineyards is more or less like that one. So we it is very important to understand that you do not need to have a cable stay bridge or a suspension bridge to make a good design. You have to do that every time. And this is another example. Georgie, how much time I have?
You have 50 minutes maximum.
50?
No, 50.
No, but how much time?
You use 45 minutes.
45, yes, perfect. I will be in time. So this is another example. This was an existing bridge. The main span is 150 meters, 3 spans of 150 meters. And it was necessary to widen the deck from 12 meters to 24 meters. And there were many conditions, but another condition was that here is the bridge, and if you needed to maintain the traffic during the construction of the widening, because otherwise you needed to do this way, so it was a long way. And you see here, this was more or less the previous situation. This is the 12 meters, more or less, and here you have the necessity to widening the bridge up to 24 meters. And we needed to understand the problem. We needed to know if the bridge was able to support 50 more years. So we made many tests, taking advantage of some of the knowledge we have at the moment to know the situation, the durability situation. I will not explain into detail, but this is only to give you an idea how in detail we were studying the durability problems, covers, and finally the idea was, we will have new loads, the self-weight load of this new part, and the traffic loads. And one possibility is to make an additional bridge in the same place, and a steel bridge. But another possibility is to say, we will strengthen the actual bridge, and we will minimize the new loads. And for that, the main idea was, we will build, we will strengthen the actual bridge. We will build a new web in the interior of the bridge. We will transfer all the new loads to this new web. And the web was built inside the box girder, and it was very difficult to do that. And then, in order to minimize the weight, we propose to use lightweight concrete. And then we use these struts, steel struts, and we to transfer the load to this beam underneath the cross section, and from here we introduce the new load in the new web. In order to improve in order to help a little bit the behavior of the actual bridge, we use some interior pre-stressing in order to introduce some compression, extra compression in the actual cross section. So then you need to develop the construction process, and it is very difficult in this case, but it is very interesting to think on that. This is the construction of the new web, which was very difficult. The deviators of the external pre-stressing and you see how these people helped us a lot. And you have there the internal pre-stressing, and at the end you have the moment in which we were casting the slab with the lightweight concrete, and how we try to accelerate the hardening process. And this is a nice picture because you see the traffic, and we were making the construction of the widening. So you have always possibilities. I only want to say one word. Even in the details, you have the possibility to have a good conceptual design. Just mentioned before that we have a strat and tie models. They are simple but very useful. But unfortunately, we are not using that. It is very difficult to teach strat and tie models because you have to think. This is the main problem. It's not a formula you get and you produce numbers. You need, in the example shown by him, you need to know that you could have an anchor problem. You have vertical or horizontal because your sketch was vertical. So and it's a very simple, but it's a very important idea. And for doing that you need to be used to think. And for that reason, this is a bridge designed by Zaha Hadid, and she's an architect. Well, this is the bridge, and we needed to participate in the construction, and I will go directly to the concept. And the first problem was to understand which could be the mechanism, the statistical system to solve this problem. And I was 1 month thinking, and these were my first sketches. Well, I can use the bottom part of the bridge to produce a box girder and to support the upper part of the bridge, but this was not sufficient. Then my idea was, well, I will use the bottom part as a cord, the bottom cord, and I will use this element as the top cord, and I can increase the distance between the bottom and the top cord. And well, this was the final idea, and then you see here the flow of forces. And then, well, I thought, well, we have here the top chord, here the bottom chord, and in between we have this grid. You can use that to transfer shear forces, but always I was using the strat and tie model, even if it's a composite structure, but mainly a steel structure. And you see all the details. We made some simple calculations in order to be sure. But you see here, it's a very crazy project. But in order to understand blue and red and compression and tension, so ideas. I will finish, and here the miracle is the built structure, and this was the initial idea from Zaha. And we need a lot of education. It is not possible to introduce this culture in our engineers, saying something in our model code. We need education. We need education. We don't. I have a subject in my university. I teach conceptual design, and I ask my students, or I tell my students, the final, the examination will be to create an idea. And they became crazy because they do not know that they are able to create an idea, and they want to a normal examination, but at the end they are able to do many interesting things. Not all are interesting, but some of them have enough motivation to do interesting things. So I am very happy to see that we have that chapter in our design part of the model code. We need to make a lot in order to take advantage of all we have now. We have tools, we have knowledge, we need to think. Thank you.
Di Prisco, Politecnico di Milano. I would like just to know which is your thought about another problem, because a long time ago Vasari told us that a good conceptual design is an equilibrium between aesthetical efficiency, functionality and aesthetics. Nowadays I see there are a lot of very good architecture, but sometimes it seems that it's much more sculpture rather than architecture. Which is your thought about it?
My answer is completely clear. We need to use our concept and we need to make efficient structures. This is sustainable. This is according to our culture. I don't want to do an architect. I want to do a good engineer. And this could be enough. So I think we need to know deeply we need to dominate our concepts in order to produce as Torroja, as Nervi, as many others, efficient structures, and using the material in the best way. We don't need to be sculptors. We need to be to do good engineering work, nothing else. Just.
I think the answer is very simple. We need to start from the requirements, and not often the architect or engineer starts from the requirements, and then to try to find the way to fulfill the requirements. We have an experience together in which
together,
in which a big building was oriented to become a monument, not respecting some requirements. Then we have to insist that first of all we start from the requirements and then try to fulfill with intelligent solution, conceptual design the requirements.
But we need to feel to enjoy doing this. Now it's a matter of architects, and this is not true. It's our job, but we are not doing that job well.
Yeah, I think I entirely agree with you that it's a cultural problem. Yeah. And particularly nowadays, most of the engineers, young engineers, are so computer savvy that these conceptual designs are fading away. Yeah. I think my suggestion is that one of the way by which you can sort of encourage more conceptual designs in the profession is perhaps to encourage more design competitions on any mega projects before actually the project starts. Otherwise, what happens is, in a design and build contract with such a tight schedule, I mean, you are actually not giving time for the consultants and the contractors to come out with, a nice conceptual design which perhaps will be addressing all the sustainability, durability, economy, all aspects.
Yeah, but I think competitions are very important. Can get from you the best, and this is very interesting. Time, you never have time. You have to be used to produce good ideas. You have to be used to work hard, and this is something you really learn if you do that every day, with every possibility. So I don't think they have to give us more time. We need to solve in the time we have what give our good solutions. But competitions I think we need to reinforce or strengthen our civil engineer position. It's very good. We need to take advantage of that. We need to be proud of that, because we made in the history very nice proposals. We don't need to be architects. We need to be ourselves. Nothing else.